All right, I see folks are still joining, but let's go ahead and get started. Welcome, everybody. My name is Zach Snyder, and I'm really excited to have you here today for our How to Go Solar and Storage webinar. I'm a program manager at the nonprofit Solar Oregon, and this is a webinar that we put on for home and business owners interested in learning about solar and energy storage, usually once or twice a month. And it's something that we frequently update. We keep very current with the market, making sure that we're bringing you the most accurate information about solar and storage. So very glad you can join us. We are going to cover a few topics here. We are going to talk first about the technology of solar and how that works. We'll look at a solar system, a couple of configurations, and we'll take a look at net metering, which is a system that allows you to take advantage of energy you export to the grid. Then we'll go through, is my home right for solar? We'll take a look at aspects of your roof and your home structure and other aspects of your home that will determine whether it's going to be easy or a little bit more difficult for you to install solar. Then we'll go through energy storage, and we'll hit that pretty thoroughly. That is talking generally about batteries for your home or business. Is an increasingly a hot topic, a topic of interest. Then we'll close out talking about incentives and the installation process and how to find a contractor. So that's the content of our webinar. This is running just about an hour. And after that, we will have an extended Q&A. I hope that the last 10 minutes or so of the hour is the Q&A. And then I usually like to stay on the line and answer any questions you have. So Q&A is definitely my favorite part of putting this workshop on. Please do not be shy about asking questions. There's no stupid questions. And please feel free to ask any questions about solar, about the topics that I cover in this presentation, or questions you have about your home in particular that I may be able to answer. Before we begin, let me tell you a little bit about Solar Oregon, my nonprofit. I've been with Solar Oregon for 3 years, but we're a 43-year-old organization. And we do a lot regarding education and community building and advocacy to encourage the adoption of solar across the state, particularly focusing on net metered solar. We do that through our How to Go Solar workshops, which is what you're at today. We also do that through solar tours. We have a series of showcases that include not just residential sites, also apartment buildings, public buildings, and other buildings that have solar that I think are interesting from a lot of perspectives. We also put on an annual Zero Energy Homes Tour called the Go Zero Tour. That's in October, and that's always been a lot of fun. We also host campaigns on a community scale called Solarize campaigns we've been doing since 2009. Most recent one was in Hood River County last year, and we hope to do another one this year. We also are a long partner of the Oregon Clean Power Co-op, and they're a provider of something called co-op solar or community solar. Feel free to ask questions about that. We have also special topic events. We've got an event coming up in March, on March 23rd this month, which is an in-person event. It's actually a home open house showcase of what are called smart electric panels. This is a breaker panel that is, think of it as breaker panel 2.0. It's got a smartphone app that allows you to control your breakers. It's a new technology. This is definitely something that is not, it's in the niche new technology kind of category. So I think it's really exciting. It's going to be really interesting. It's in Northeast Portland. That's another free event, and you can find that on our website. And feel free to join us for that. We also have a series of free educational webinars called the Green Energy Series, which was started up late last year by a few of our board members. One of them works at the Pacific Northwest National Lab. He's an energy efficiency researcher named Edward Louie. He's been leading a lot of these presentations. They're monthly on the first Saturday. The next one is on April 1st at 10 a.m. On Zoom, and it's going to be about inverter and battery choices. Should be interesting if you want to tune in for that as well. Here is information about how to donate and support our nonprofit. We really appreciate all of your support. We're a member supported nonprofit, so thank you to anybody who's on the call who's a member. I'm going to go ahead and drop some links in the chat, which I'm going to refer to throughout the webinar. I'll also post them at the end of the webinar again in the chat. But you'll find our website, you'll find a donation link. You'll also find other tools and resources that will be interesting for you. And finally, I want to mention Energy Trust of Oregon, which is a statewide independent nonprofit. There's been around since, I wish, I'm gonna mess up the year, but they've been around for a little while. They're big. They provide a lot of the incentives for solar, for energy efficiency to customers of Portland General Electric and Pacific Power. They also work with the gas utility customers, and they also support our education about solar. So you can thank Energy Trust of Oregon for the information that we're going to present here today. Just a couple of quick housekeeping notes. Please feel free to use the chat and say hi. However, if you have questions, and again, I love your questions, please don't put them in the chat, put them in the Q&A box. And so if you don't see your menu, you can mouse over your screen and you should see a button that says Q&A. If you click that, it'll open a box and you can type in your question. You can do that whenever throughout the presentation. You can do it right now if you already have questions. And we will answer those again during the Q&A section, and I'll try to answer all of them. So feel free to really use that. Last thing before we get started, I have some polls for you. These are really handy to help me to get to know who you are, where you're tuning in from. The first one is about your location. And so please, if you would, just click whichever response is most appropriate for you. And we're kind of zooming out across the state and beyond. I'm just going to give a few more seconds here. Looks like you folks are pretty quick. All right. So looks like we've got folks in Portland and then also a couple of folks in Eastern Oregon. So welcome. Thanks so much for joining. One other, sorry, we have two more polls before. This is an optional poll, just anonymous demographics information. If you like, it helps us in our reporting for our funders. It's much appreciated. And I'll just give a minute here for this one. There are several questions. All right. Looks like we are pretty much wrapped up here. Thank you so much. And the last poll before we get started is a quick one, a couple of yes or no questions, excuse me, asking if you're familiar with a couple of the incentives offered by Energy Trust of Oregon. One of them is the standard solar incentive. That's just a yes or no. And the other is Energy Trust of Oregon's Solar Within Reach incentive. Just if those ring a bell, hit yes. If not, click the no or the maybe. And I will give just another second here. It looks like you guys are pretty quick. All right. Yeah, it looks like the majority of people are not familiar and a couple of people are. So that's great. And hopefully you will all be familiar. That's our goal by the end of the webinar. So without any further ado, let's jump straight in and talk about how solar works. Here's a little diagram of a solar system. It's relatively simple. We're going to work from the left here, the top left, toward the right. The solar panels are going to be placed on your property, and usually that's on the rooftop. I'll give an example of how that can be mounted in a couple of slides. You'll see that this is labeled photovoltaic panel. That's another name for solar panels. You also see that PV panel. When the sunlight strikes the PV panel, the solar panel, it will produce a voltage of electricity, and it's just that simple. However, the type of electricity that is produced by your solar panel is going to be a form called DC electricity, that's direct current. And the type of electricity your home uses is called AC electricity, which is alternating current. Now, if this is too technical, don't worry about that at all. All you have to know is that there's a special device called an inverter, or sometimes you'll have multiple smaller microinverters that perform that conversion from DC to AC electricity. From the inverter or microinverters, the electricity goes and gets wired into your home electrical panel, and that is the breaker panel usually in your garage or somewhere else in your home. And from there, the electricity goes to power all the circuits in your home, including your lights, your appliances, maybe an electric vehicle if you have one and you're charging one there. If you are producing more electricity at any given moment with your solar system than you're consuming in your home, the excess electricity will flow out through your utility meter and back onto the utility grid, where it can go to power other homes and businesses. When your home is consuming more electricity than your solar system is producing, for example, in the evening and nighttime when you come home from work, the grid is still there, you're still connected to it, and you'll be able to still purchase electricity from the utility. Now, when you get solar, you're going to have your utility meter swapped out because your utility meter, a standard classic utility meter, only records the electricity coming into your home from the utility grid. And that will be swapped out with what's called a bidirectional meter, which allows you to record the amount of electricity going into and out of your home. And with your bidirectional meter, you'll have the ability to take advantage of a program called net metering, which I'll talk about in a couple of slides, which is key to getting the most value out of your solar system. That's available for the vast majority of utility customers in Oregon, including PGE customers and Pacific Power customers. The folks in more rural areas, depending on where you are in Eastern Oregon, for example, if you're a customer of a electric co-op, you may or may not have access to net metering, but I'll talk about that again here in a second. Let's take a look at the device called the inverter or microinverter. Inverters are the device, again, that converts from DC electricity to AC electricity. On the left, we see a string inverter, and that is this white box here. It's on the outside of a home, pictured here. Oftentimes, it's as close to the electrical panel as possible. So if your electric panel is in your garage, which is very common, and you have wall space next to your electric panel, that's where your inverter goes. Alternatively, the picture on the right here is of a ground-mounted solar system so that we can see underneath it. But the reason we want to see underneath it is because that's where the microinverters are. That's these black boxes. You can see that there's one for every 1 or 2 solar panels, depending on the microinverter. And they do the same exact thing as the inverters. You may be asking the question, okay, how do I know if I need inverters or microinverters? And that is something that your solar installer is going to be an expert at, and it's going to depend on how they design your system and the design choices that they have based on your needs. So they'll be able to answer why you would pick one or the other, but they're both great configurations for solar. When it comes to where you can mount solar, you can mount it on the roof, which is incredibly common. That's by far the most common place to mount a net metered solar system. And that has a lot of advantages. There's just space on your roof and it's sitting there baking in the sun. You may as well put some solar panels there. Alternatively, if you have the space, for example, if you're in a more rural area, you could consider potentially a ground mount, and that is what's pictured here on the right. Ground mounts and roof mounts are both great options. However, ground mounts, because you have to trench a wire from the solar panels back to the electrical panel where the breakers are, and you have to string that long copper wire. The trenching and the copper itself can be expensive. So if your ground mount is far away from your home's electrical panel, that can increase the cost of the system a little bit. Now, I'm going to take a detour here for one slide to talk about what is a little bit of a niche product called solar roof tiles. And this is something that accounts for relatively a minuscule portion of the solar market in Oregon. And it's not what we're talking about in the rest of the webinar today. However, we get a lot of questions about this because there have been a lot of marketing campaigns regarding solar roof tiles, and some folks just find it naturally an interesting technology. So the first thing to know about it is this is a little bit of a newer technology, and it is a more complex technology from an engineering perspective. What that means is that it's going to be more expensive, and additionally, it will take longer to install. If you're interested in solar roof tiles, they're not installed by the vast majority of solar installers. There are multiple products available. You usually have to find a very specific installer or the manufacturer themselves who will install it for you because this is such a niche technology right now. There have been many promises in marketing campaigns regarding price declines that the manufacturers believe are imminent. Those in the past have not materialized. Who's to say when the price will decline? However, my guidance would be that if you're considering solar and you're considering solar roof tiles or traditional solar more likely, just don't wait to go solar based on promises of declines in price in the future, since those often are a little bit harder to predict. Now let's talk about net metering. Again, this is the system that allows you to gain credit for the energy, the excess energy from your solar system that you're exporting to the grid. Again, this is not necessarily available in all rural co-ops, though the vast majority of utility customers in Oregon will have access to net metering. That includes Portland General Electric and Pacific Power customers. Here are a couple of graphs that will help to illustrate how this works. The graph on the left, the orange bar is the amount of electricity that your solar system is producing in a typical sunny summer month. You can see it's a pretty high orange bar here. That's right next to this blue bar, which is the amount of electricity that, say, you're consuming that month. You can see that your solar system in a sunny summer month might produce more than you're consuming. In fact, that is likely. And the difference here with the green arrow is going to be your net metering credit earned. That's going to roll over to future months. So let's fast forward here to a typical cloudy Oregon winter month. You can see that the orange bar is much lower. You're producing much less solar energy. Excuse me. And it's less than the amount that you're consuming in that month. And you can see the red arrow shows the difference. And that's what you are purchasing from the utility in that month. Because you have these rolled over net metering credits, you can use that to offset what you have to purchase in these cloudy months. Now, it's important to note that net metering credits, while they roll over from month to month, excuse me, just getting over a cold here, they don't roll over from year to year. The net metering year starts on April 1st. And so from April 1st, you're starting to bank a bunch of credits in the summer. You use those in the winter. If you have excess credits on March 31st, those are going to be forfeited. This is going to have some implications for your system size, which I'll talk about in a second, but that's the gist of how net metering works. All of this translates, of course, to a reduction on your energy bill cost, your electricity bill costs. Here is an example real energy bill from a PGE customer who has a net metered solar system. And we're going to walk through this so you can see what your bill will look like if you are a net metering customer. You can see the meter start and end both consumption and generation readings. So that's that bidirectional meter. It records the amount of electricity you consume separately from the amount that you export. In this case, this family consumed 237 kilowatt hours of electricity, but they generated 564. So they gained 327 net metering credits. That means that they are going to be billed for 0 kilowatt hours this month. And this is their total banked net metering credit. You may be surprised if you look over on the right to see that they're still going to pay $12.63 this month. The majority of that is for this basic energy charge, which is $11. And excuse me, that is essentially what you pay to be tied to the grid. Anybody who's tied to the grid is going to pay that $11 a month. And there's a lot of advantages, of course, to that. There are also a couple of line item taxes and fees here amounting to $1.40. However, this is going to be much less than this person's typical $70 to $120 utility bill. So that's the difference between having solar and not having solar. Lastly, let's take a look at the size of a solar system and how solar systems are sized. Solar systems are incredibly customizable, and they can be built as a very small system if that's what meets your needs, and they can be scaled up essentially infinitely. There's going to be, space constraints which are going to limit the size of your system, but you could build a system as large as you want, technically. The main thing that's going to limit your system size is it's going to be based on how much electricity you consume, for the exact reason that I just mentioned with regard to net metering, that your credits are forfeited at the end of the net metering year. So you want to meet but not exceed your estimated annual energy consumption with your solar production. That's something that solar installers are really good at doing that. They'll ask you for your past utility bills. Make sure you tell them if you're getting new appliances that maybe will consume a lot of electricity, like an electric vehicle charger, or switching over your water heater or other appliances to electric. Other factors are, as I mentioned, available space on your roof. Maybe you just want to install a portion of your possible system size due to budget constraints, and you want to install another segment of the system later. That is often possible. You want to talk with your contractor to make sure that they design your system initially so it can be expanded as easily as possible. Even if your system does not offset 100% of your energy, it can still be a great investment and with a similar proportional return on investment. One final note here is that systems sizes are measured in a unit called kW, that's kilowatt. And the average system size is plus or minus 8 kilowatt, which we'll mention when we go through an example budget later on. That's the basics of how solar works. It's really simple. Hopefully that answers some of your questions. Let's take a look now at the aspects of your site, your home, that will determine whether it's easy to install solar. The first thing we're going to take a look at is your solar access. And that is how much sunlight you get. So here is a hypothetical home with a hypothetical solar system. On top of the compass rose, you can see the directions, north, south, and then there's east and west. And this arc, these two arcs, are the path of the sun in the summer and the winter over the home. You can see that regardless of whether it's summer or winter, because we're in the northern hemisphere above the tropics, the sun's always going to be in the southern sky. And what that means is that south-facing roofs are ideal for solar. However, east-facing roofs and west-facing roofs can work just fine. Typically, I'd say southeast to west-facing are ideal. The only direction where you don't really see solar being installed is if it's oriented from the northwest to roughly the east. Again, that's something your solar contractor is going to take a look at for you, but that will determine your solar access. Of course, you could have a perfectly south-facing roof and be thwarted by shade. That's unfortunately not too uncommon in Oregon. However, it can be hard to tell whether that is going to be the case for you just by taking a look, as an amateur roof gazer yourself at your own roof. Solar contractors are really good at telling if the tree that's in your yard is going to, or in your neighbor's yard, is going to block the sunlight at that critical hour that is going to be where the peak generation occurs. So don't despair if you do have trees, certainly celebrate that. Some aspects of the roof are really important to your solar prospects. One of those is the geometric complexity of your roof. So let's take a look at two roofs on Google Maps here. The one on the left, I would characterize as a complex roof. You can see all these different roof planes. It's very cut up and it looks cool, but there's not a whole lot of continuous space for a solar system. You might be able to install a small array on a couple of these little panels, but there's some awkward shapes in here. And it's not quite as efficient to install solar with a bunch of small subarrays, although that is relatively common. It does happen. A much better situation is if you have a simple roof geometry like the house on the right, which even though it's a smaller home, you can see that there's a great south-facing roof that is relatively continuous except for this dormer over the garage. Next, and probably most importantly, regarding your home structure is your roof condition and age. And this is important because when you have to re-roof, you can't really postpone that, and your solar system will have to be uninstalled, your roof will be replaced, and then your solar system has to be reinstalled. The labor for uninstalling and reinstalling a solar system is particularly pricey because it involves functions that electricians have to perform. And the service might run more or less $10,000. So it's something that you really want to make sure happens at the end of the lifetime of your system, not toward the beginning of the lifetime of your system. For that reason, it's highly recommended that you have a roof life that is over 20 years left on the roof. This is important for a number of roof types. Metal roofs last a long time, so it's typically less of a concern there. If you are in the position where you know you'll have to re-roof in the next few years, it's best to wait until you re-roof and then get solar. And in fact, that's the ideal time to get solar, is right after you re-roof. Finally, what's underneath your roof is also important. We're talking here about your roof structure. You can see, I'm going to break this up between trusses and rafters as two different types of roof structure. You can see in the image on the left that in the attic here, there are a lot of support beams, both vertical ones on the side and horizontal ones up top. You can even see these metal connection plates. These are prefabricated trusses. This is really common in newer homes, and you shouldn't have any issue getting a structural permit for your installation with trusses. So if you peek in the attic and this is what you see, there should be no problem. You also may have no issue at all if you have rafters, and rafters are where there are no support beams. It's just the rafter going from the eave to the crest along the roof plane. And that can be no issue. It's mostly an issue within the jurisdiction of Portland. And in Portland, it's mostly older homes, and particularly urban craftsman homes have a lot of trouble getting structural permits in Portland. What would that look like if your rafters do not meet code requirements right off the bat? First thing is that if you're in Portland, the Portland permitting office is going to require that your solar contractor hire an engineer to run some calculations and make sure that your rafters do meet code if it's questionable. If the engineer comes back and says that it meets code, then the permit will be issued and you should have no further problems. If the engineer says this does not meet code, then your solar contractor will have to install some reinforcements in your attic. It's going to be, they're going to have the space to get in there and perform that work. So if you have a particularly cramped attic, it may not be possible at all. And that would be a case in which you could not go solar. However, if they can perform that work, it can cost $2,000 to $3,000 for the engineer to take a look and run those calculations, and an additional potentially $3,000 to $7,000 to perform the structural reinforcement work. So that can add cost to your solar system. Again, mostly an issue in Portland, but something to think about. Hopefully that gives you an idea of how to assess your home on your own. Again, your solar contractor is going to make these assessments for you, so you don't have to be an expert. Let's take a look now at an exciting topic of solar and battery storage. This is particularly important in the context of when the grid goes down. So here you can see a power outage and a building that happens to have access to a backup power system that is still able to use its power during the outage. This is afforded not actually by solar alone. If you have just a solar system, you won't be able to use the power from your solar system when the grid goes down. That's for some technical reasons that are inherent to the grid itself. However, if you add a battery to your system, that is what allows you to use your power when the grid goes down. And in fact, solar makes battery storage more effective because it can recharge the battery, and a battery makes your solar more effective because you can use it during an outage. So I like to say that these are like peanut butter and jelly. This is what we're talking about here is, say, a battery in the garage and some solar panels on the roof. Why does energy resilience matter? There are different types of power outages. So here's a few different ways to think of this. The vast majority of power outages, especially if you're in a more rural area toward the end of the line, as people say, the vast majority of short duration outages that you're going to experience are caused by things like storms and squirrels chewing on lines. If you get those kind of outages, you're likely aware that you're that type of person, and that may be a great use case for solar plus storage. Additionally, there is something called a public safety power shutoff that can result in you losing power. This really started in Oregon in 2020 and has happened a few times in the years since then. It's a protective measure that the utility takes during high fire risk weather events, for example, high wind, high heat, and they turn off parts of their distribution grid in order to prevent sparking a wildfire from their infrastructure that runs through the forests at those times. That can last a little bit longer, sometimes a whole day. And that's something that battery solar plus storage can also be a good use case for. Additionally, we live in the Cascadia seismic hazard zone, and we all know that we're expecting a big earthquake, potentially up to a 9.0. It's thought that even in the Willamette Valley, the power could go off for up to 6 weeks, which is quite a long time. Maybe not something that a typical residential solar plus storage installation can handle. So make sure that you know what you're planning for and why you want solar plus storage, and that you communicate that to your installation company as they're designing a system for you. When it comes to picking a battery, the great news is there are a lot of different products to choose from that are high quality and UL listed. The vast majority of batteries that are for residential grid-tied systems use a lithium ion chemistry. However, the lithium ion chemistry is more of a family of chemistries, and there are two in particular that are relatively common. One of them is nickel, manganese, cobalt, and that is it's a great technology, relatively cheaper, and you can contrast that with lithium iron phosphate, which is a little bit more expensive, but may have a longer overall lifetime. Your contractor will be able to walk you through those differences. However, most contractors specialize in one or maybe two brands of battery that they install. So if you want to get a comparison between multiple different types of batteries, you may have to get quotes from multiple contractors, which I would recommend for a number of reasons anyway. The components cannot be mixed and matched between brands. However, you can mix and match components within a brand. And typical battery sizes are between 9 and 14 kilowatt hours. There are also sometimes manufacturers will make a 3 to 4 kilowatt hour little mini pack that can be added onto your system just to boost the capacity a little bit. Or additionally, some manufacturers make a supersized battery that has up to a 20 kilowatt hour capacity. One additional thing to think about beyond the capacity is the amount of instantaneous power, instantaneous current that the battery can provide. And that is relevant in the case that you have appliances, especially motors, that might draw a lot of power, have a spike in their power consumption momentarily, just for a fraction of a second. That's something that if you do have motors or other high, momentary power consumption appliances, just make sure you mention that to your contractor so that they can factor that in. Now, when you get a single battery for your home, most likely what you're going to have is what's called a partial home backup. A partial home backup is where only a portion of the circuits in your circuit breaker are going to be tied to the battery. All the other circuits are going to lose power still when the grid goes down. This means that you're going to have to be selective, and you're going to have to think through what you want your battery to do. This is the case because a typical battery typically can't back up your whole home. However, some people do want to put up the extra money to buy multiple batteries, which can allow for a whole home backup, in which case you don't need to worry about a partial home backup. These are both great options, and partial home backups are by far the norm. When you get a partial home backup, what happens is the electrician at your installation company will actually move the breakers into a separate breaker panel. It's going to be installed near your original breaker panel called the Essential Loads panel. So what you do is you go in and you point to the breakers that you want, and they move those over. Of course, that does add a little bit to the complexity and therefore the labor costs of the system. But partial home backups are still typically quite a bit cheaper than whole home backups. When you talk to your contractor about designing your system, you're going to be balancing essentially the answer to two questions: what needs power and for how long? For a partial home backup, typically people will back up a refrigerator to keep their food from spoiling, some lights in common areas, and maybe some outlets for charging a computer or a laptop or a cell phone to make sure you can work and communicate during an outage. If you add things to that list, especially high energy use items like a space heater, that can decrease the amount of time over which you can expect your battery to effectively power all of those appliances. And so that's where this balancing comes in. Now, one of the great things about solar and battery technology is that it's extremely customizable. And when your solar installer designs your system, they're going to choose components that are as well matched with one another as possible. That means that your system is going to operate very efficiently. It's going to meet your needs, and you're not going to have to pay for a lot of equipment that you're not utilizing actively. Excuse me. One caveat to that is that after your system is initially designed and installed, adding on to that system or modifying it electrically can introduce inefficiencies, and you might then be paying for additional equipment that's not as efficient overall, even though it might work great. This is important in the context of when you install battery storage, and there's a couple of different ways in which you might be looking at this. You might be a homeowner thinking about solar plus storage and wondering if you can just install the solar now and then install the battery later to try to stagger those costs. Or you may be a homeowner with an existing solar system wondering if it's possible to add a battery to an existing solar system. The great news is that it is often, yes, it is possible to add a battery to an existing solar system. However, it can increase the total cost if you take into consideration both the solar and the battery when you add the battery later on as compared to installing the solar and the battery at the same time, because, as I mentioned, these are customizable technologies, and the initial system design will make it the most efficient for you. What that might translate into, and this is hard to quote exactly, but it might be up to around $10,000 total difference in the cost if you are to add a battery later after your solar is initially installed, compared to adding the battery when your solar is initially installed. But it can still be a great option for folks who have existing systems. Finally, batteries, all of this equipment, including batteries and inverters, they do require some wall space. The best place to install your batteries and your solar inverter and any battery inverters is right next to your electrical panel. The system shown here in the image is a particularly large and complex system. It actually has 4 batteries. But you can see there's a lot of wall space taken up here. You cannot install batteries or inverters in crawl spaces or cupboards or other enclosed spaces, but you can install them outside on the side of your home. This is governed by the very august National Electric Code. These rules are put in place. They're great rules put in place to protect you and make sure that the technology is going to work optimally for you. So nothing to fret about. That is an overview of solar plus storage. Let's take a look now at an example budget for solar plus storage in just solar. And let's also take a look at the incentives that are great that you have access to in the state of Oregon. There are 2 principal incentives that most people have access to, which are the federal solar investment tax credit. That is a 30% dollar for dollar tax credit. And then additionally, there is the Energy Trust of Oregon $500 cash incentive, which Energy Trust of Oregon incentives, this is not the only one. They are available to customers only of Pacific Power and Portland General Electric. That is the majority of people in the state, but if you're in Eastern Oregon, you won't have access unless you're a Pacific Power customer, which could be the case. But if you're a co-op customer, you won't have access to the Energy Trust incentives. Here's a little bit more information about the federal tax credit. This is an awesome incentive. It's been around for over a decade. It's really driven the growth of the solar industry. And legislation last year renewed the incentive as it was about to expire. So now we have it for a while longer. It's the only incentive that you are going to apply for, at least of the incentives I'm going to mention, which are the ones that are relevant to homeowners in Oregon. It's the only incentive that you will apply for on your own, or you'll have a tax professional apply for you on your behalf. What this means is, first off, you will apply for this after your system is installed, and it's claimed on IRS forms 5695, and additionally on information you have to enter on IRS form 1040 Schedule 3. It's relatively simple. You can find the instructions online and review it. In the vast majority of cases, it's going to be a very simple thing to apply for. If you have special questions about what qualifies for the incentive in a specific niche case, and you have questions that you want answered, I would say only trust a tax professional. Solar Oregon is not a tax professional. However, there are tax professionals who do help us review our content. So take everything we say with a grain of salt, but the great thing about the solar investment tax credit is that it applies to both solar and battery storage, at least as of this legislative update last year. So that's a great expansion. Before it was just solar, now it's both. If you do need the tax liability, you cannot get this as a tax refund, essentially. That's not the word, but the word is blanking in my mind. So you have to have the tax liability. If you don't have tax liability, you can't take advantage of this. If you don't have enough tax liability over 1 year, however, it can be claimed over multiple years. Now I'm going to talk about a couple of other great incentives that I didn't mention before that are Not everybody is eligible. These are both income qualified incentives. One of them is from Energy Trust of Oregon called Solar Within Reach. It is an awesome incentive. It's up to $6,000 for Pacific Power customers and up to $7,200 for Portland General Electric customers. It's based on the size of the system. And so you can see it's $1 per watt for Pacific Power, $1.20 for Portland General Electric. It is income qualified, meaning that if your family income is above the threshold, you won't qualify. If it's below the threshold, you will. This is a relatively generous threshold. So for example, a household of 4, if your income is below $112,860, you will qualify for this incentive. So that can make a huge difference. You can find more information about this incentive in the links that one of the links I posted in the chat previously. The other income-based incentive is offered through the Oregon Department of Energy. This is for anybody, not just in Energy Trust territory, in the state of Oregon. It's up to $5,000 for solar and up to an additional $2,500 for battery storage if your battery storage is installed at the same time as your solar and is tied to that system. This was a general incentive. It started in 2020. There are still plenty of remaining funds, but only for the income qualified portion. The income threshold is different from that for solar and reach. So just keep that in mind. You may qualify for solar and reach, but not for the solar plus storage rebate, which is a little bit of a more conservative threshold. I'm going to show you a couple of example budgets. It's typically people's highest priority slide. People really like this information because everybody's wondering, how much does solar cost? How much does energy storage cost? However, I'm going to give you this information framed with the understanding that costs can vary significantly, both for solar and for energy storage, though particularly for solar. Reasons that solar system cost can vary include the size of the system, which can vary dramatically, whether you need to re-roof, and whether you need any structural analysis or upgrades. Again, that's going to specifically apply mostly in Portland, as well as your access to incentives. Additionally, storage costs can vary based on whether you're installing a battery with a solar system or installing a battery to an existing solar system after the fact. It can vary based on your choice of battery, the number of batteries, of course, whether you have a partial home backup or a whole home backup, and how far away your equipment is installed from your electrical panel due to labor costs and electrical conduit costs. It can also vary based on access to incentives. But with that in mind, so please take this with a grain of salt, let's take a look at an example solar budget for a hypothetical 8 kilowatt solar system. We are going to assume a pre-incentive cost in both Pacific Power and PGE territory of $32,000. That's the cost for every aspect of the installation of your system. There are 2 incentives here that you may have access to: Energy Trust standard incentive or solar within reach incentive, and the state rebate. So you can see that these 4 columns, I break this up based on the 2 left columns are for the 2 main utilities. If you don't qualify for any of the income-based incentives, the 2 right-hand columns that are labeled LMI, that is if you do qualify for both income-based incentives. So we can see here that on the left, folks in both Pacific Power and Portland General Electric are going to receive a $500 Energy Trust incentive. However, if they have access to solar within reach, that's going to jump to $6,000 or $7,200 respectively. With the state rebate, it's not going to be available for folks who are not income qualified. Folks who are with an 8 kilowatt system, it's going to be maxed out at $5,000. Your installer will apply for and receive and pass on to you both of these incentives, which is great. It's not a hassle for you in the slightest, and it's all going to be taken care of. which means that your out-of-pocket cost for this system is the line that you're really likely going to want to pay most attention to here. For Pacific Power customers and Portland General Electric customers, that's going to be $31,500. So roughly the same, minus that $500 Energy Trust incentive. However, if you qualify for these income-based incentives, that gets taken down to roughly $20,000, maybe $21,000, depending on your utility. So you can see that those incentives make a huge difference. This is what you pay out of pocket for the installation. Later on, you'll be able to claim the 30% federal tax credit if you have tax liability, bringing the net installation cost to roughly $22,000 if you are not income qualified, or roughly $14,000 if you are. So you can see there's a bit of a difference there. Hopefully this gives you a general sense of how much solar costs. Again, this will vary based on your situation. I'm going to show you two more budgets, example budgets. I'm not going to walk through them in quite as much detail. They're both for solar plus storage. That's solar plus a battery. And we're assuming an 8 kilowatt solar system with a 10 kilowatt hour storage system. And the first budget I'm going to show you here is assuming that your battery is installed at the same time as your solar system. And this is the cost for both the battery and the solar. Next, I'll show you the same system, but if you add the battery after the solar is already installed and designed. So here, installing at the same time, our assumed cost is $44,000 before incentives. Your out-of-pocket cost is going to be roughly $43,000 if you are not income qualified. If you are, that's going to drop down to roughly $30,000 if you are income qualified. And again, this is for both solar plus storage. Then your federal tax credit is going to bring the net installation cost, again, after you claim the credit, which could take 1 year, could take multiple years if you need multiple years to claim that full value, is going to be $30,000 if you're not income qualified versus roughly $21,000 if you are income qualified. Again, solar plus storage installed and designed at the same time. Now let's take a look at solar with a battery added after the fact, say the next year or a few years down the line. Same basic deal. And here the assumed cost for solar is around $32,000. The cost of the battery is going to be $23,000. And let's walk down here to the out-of-pocket cost is going to be roughly $54,000. So compare that to the $43,000 in the previous case. Or if you're income qualified, roughly $44,000, $42,000, roughly $10,000 more than if you were to install the battery at the same time. Now, the net cost is going to be brought down to roughly $38,000 if you're not income qualified, or roughly $30,000 if you are. Hopefully these budgets are useful, and hopefully they don't raise more questions than they answer. Obviously, you're going to want to take a look at the quotes offered to you for your actual system that would work for you on your home. One final note about the cost of solar and battery storage is that financing is relatively common because, of course, there can be a significant upfront cost. There are financing products that are offered by credit unions and third-party providers that are tailored to solar. And what that typically looks like is the ability to refinance the loan after you claim the federal tax credit, getting you a better interest rate for the last portion of the loan. You can sometimes find a good provider of these from an installer. They may be, your installation company may be partnered with a credit union, excuse me, or other provider that allows you to use those financing products. You may also approach your own bank. If you have a mortgage out, for example, sometimes your bank will allow you to take out a line of credit that has favorable terms because you already have a mortgage with them. Depends on your bank. Regardless, the terms of these financing agreements do vary. As with all major financial decisions, make sure that you read all the fine print and know exactly what you're getting. However, this can be a great tool for solar and storage. Now, finally, last few slides here. Let's take a look at how you get started with solar plus storage. When it comes to choosing a contractor, I would highly suggest, no matter where you are, that you consider and likely select an Energy Trust of Oregon trade ally. This is an installation company that has been rigorously vetted and qualified by Energy Trust of Oregon. This is one of the services that Energy Trust provides for the industry, and it's really handy. The Energy Trust trade allies are the only installers who are going to be able to get access to the Energy Trust of Oregon incentives, which includes that solar within reach incentive, if that's something that applies to you. And they're just great installers. There are many trade ally installers. If you are wondering how to find good contractors, there's an excellent tool that I linked to in the chat. I'm going to put in the chat one more time here. And that is under the Energy Trust-solar bid tool. It's the energytrust.org/solar bid. If you're going to save any link from this webinar, save this link. This is a great one. It leads you to an online form on the Energy Trust of Oregon website. You fill in some basic information about your address, your contact information, and what you're looking for, and they will connect you with 3 trade ally contractors who serve your area. And it's a great way to get to figure out where some good contractors are who serve your area right away. Finally, let's take a look at the installation process itself. Solar is a turnkey service, meaning that your contractor, once you sign your contract, you say you found a good contract, they provide you a good quote, and you're ready to move forward. As soon as you sign, your contractor will take care of all of the details of your installation, including applying for permitting, doing your initial system design, applying for your energy trust and state rebate incentives. That can take some time. Depending on where you are, typically it might take a couple of months. However, in places where there is a significant backlog in permitting, which did materialize in some places, especially Portland during the pandemic, for a lot of reasons, there can be a bigger delay. So in Portland especially, but in some other places, I've heard of delays up to even 12 months. However, that's before any ground is broken on the installation. So it's just waiting. It's not necessarily a nuisance to you, having people disrupting your home or anything like that. But there is that waiting period sometimes depending on your location because of the permitting. However, once your permits are issued, your solar contract will get you on their calendar. The installation on a typical residential system typically takes 1 to 2 days. So it's relatively uninvasive. A lot of that work happens on the roof, and only a portion of it happens by your electrical panel. Your contractor will then manage all of your inspections, the interconnection with the utility, and setting up net metering, and getting your bidirectional meter swapped, that might take a few weeks, 2 or 3 weeks. However, when that happens, your system is turned on by your contractor and you're going to be producing clean, renewable energy from your rooftop. I know that that was a long webinar. We've pretty much run up on the hour, so excuse me for that. I'm very excited to get into the Q&A. I've got a couple of notes for those of you wanting to jump off if you do at the hour, if you have to. One of them is that this has been recorded, and you'll be receiving a link to the recording on YouTube. So you can see that after the fact. I've got a post-event survey that I'm going to launch here. I'm going to leave up for a few minutes. That's information that helps me figure out if we're doing a good job here. So your feedback is much appreciated. Now, without any further delay, let's get to the Q&A. Looks like we've got 4 questions teed up. Feel free to keep on adding them on here. I will stay on until we've answered all your questions. Mike Grabner asks, regarding roof mounts, how could that affect firefighting efforts should we experience a home fire? My understanding is that there used to be some controversy around this. Thanks. That's a great question. So the National Electric Code, which I mentioned, which governs a lot of the rules of how solar systems can be installed, is really put together by firefighters and for firefighters, as well as with your safety and security in mind. And that's because firefighters, if there were to be a fire in your home, need to do certain things. They need to get on your roof, cut a hole in your roof to let the smoke vent out. And so that's pretty well thought out, and it's thought out in the National Electric Code. Any past controversy was likely part of the reason why the code is so good right now. Essentially there are walkways around the perimeter of solar that are necessary. So you can't just cover a whole roof plane on solar. And also there are a lot of other precautions taken for firefighters to make it so that they can do their job. So the gist is that the National Electric Code does a really good job at making sure that you'll be protected in that case. Jane asks, unfortunately, I have been called away. Will you be able to send me the recording? Yep, we will definitely send you the recording, Jane. I imagine you probably already took off. Lori asks, the installers I have quotes from are not recommending storage at this time. Apparently, storage technology is not as advanced as solar panels. Is this still the case? This is not the case. No, there's a lot of storage is a newer technology, but a lot of these products, they're UL listed and they're good products. The way in which the battery industry is learning mostly has to do with how to quote storage systems. And the storage systems, they work great. And there are installers that have more experience than others with installing them and designing them. I would recommend that you always work with a contractor that has experience, first and foremost, with battery storage. And the folks who do, they're learning, how to quote effectively. But the technology is reliable and works well. So I'd be interested to learn more. If you have any follow-up questions about that, feel free to email me, and I'm happy to sift through that if you want. Another question here, what is the current kilowatt cost in Oregon? That is a great question. That does vary based on your rate class, and that does vary based on whether you have are a customer of one of the investor-owned utilities, which is PGE and Pacific Power, or whether you're a customer of a rural co-op. The rate cases are set by the state regulatory agency for the investor-owned utilities, and it's roughly, I believe, for most residential customers, going to be around 11 cents per kilowatt hour. We have relatively cheap power here in Oregon because we have access to cheap, abundant hydroelectric power compared to the rest of the country. Of course, energy costs do increase over time. Typically, it's estimated around 2% cost per year over time. So that's a qualified answer. Hopefully that answers your question. Todd Green asks, a couple of years ago, I talked to a couple of companies that wanted to have us finance through them. In essence, we pay them our electrical costs instead of the utility. And that is how you finance it out 20 plus years. Thoughts on this? Likely what you're talking about, Todd, is not technically financing, but solar leasing, if I'm understanding the situation in your question correctly. And that is something that it was not covered in our presentation. it is something that you might consider. There are folks who provide that and have provided that. The difference is between whether you own your system and you pay for the system upfront on your own. You might get financing to do that. Solar, excuse me, leasing is where the installation company actually will own your system. And so you'll receive the energy savings, and then you pay them a portion back of that energy savings to compensate them based on a payment structure that is in the initial contract. My notes on that is that those types of contracts, of course, can vary like any kind of financial arrangement. So it really does depend on your specific offer that was made to you. And it's not necessarily a better or worse solution. However, note that financing can be another way to avoid the upfront cost, but actually retaining the ownership of your system. Again, it kind of depends on the situation and the offer made to you with regard to leasing. Mike asks, Zach, you mentioned a typical home-based a residential solar plus storage system will not handle a 6-week power outage from a potential earthquake. So what kind of power outage would an average system handle? A few hours, a day, a week? That's a great question. And this is a difficult one to answer. Certainly, it depends on how your system is designed. The products that you choose, that your installer chooses in the design. You know, for a typical, and also, sorry, based on your appliances and how much energy you consume and how you use those appliances during an outage. So it depends also on your behavior. So there's just a number of factors that go into it here. And that's why there's an upfront conversation that's relatively involved with your installer when they're making those design choices. However, it is not uncommon to have a system with a single battery that if you're just backing up, you know, partial home backup, say you got a refrigerator or a few lights, that can last a few days, potentially longer than a few days. But it's also possible if you have a lot of appliances and you use them a lot during the outage and your system is designed to be a little bit smaller, that it could be, you know, it could withstand like a several-hour outage, but not a day-long outage. That is also possible. And I would say that that's the general functional range, with the footnote that things do change over time. Batteries do increase in their capacity. And there are ways in which you can modify your behavior to make your battery more effective. And it's just a complex question to answer, though hopefully that does give you a better sense. Question about effects of homeowner insurance with adding solar. That's a great question, and that does depend on your insurance policy. There may be stipulations in your existing policy, and whether or not your insurance policy, whether that would, you know, have any effect on what's covered with your insurance policy. Conceivably, it could affect coverage with regard to your roof. If there's a rule in your existing policy, I don't know how common that is. I should know that, and it's something I should research. Additionally, you may be wondering if your existing policy might cover a solar system. I think that is typically very possible, just by calling your company and adding that as an additionally insured thing, unless your policy might just cover that by default. But again, it does depend on your policy and your company. Lori, I'm trying to do these in a round robin style. Lori asks, could you speak to compatibility again? I was reassured that my panels would be compatible with storage other than Tesla. FYI, I started this process in early November and was installed by an activator by mid-January. Yeah, okay, so that's a great question, and a good, you may have caught that I mentioned that battery components, you can't mix and match between brands. That is true for battery components, and that is batteries themselves and say a charge controller or an inverter. Though inverters, you might be able to mix and match brands. However, you can't mix and match the battery modules themselves. When it comes to mixing and matching solar panels and battery companies manufacture products, you can mix and match all the time there. So there's no problem with that. If that's your concern, hopefully that's what you're asking about. But thank you for asking that. I'm going to put that in my future, when I mention that in my future webinars, that you can mix and match solar and storage manufacturers. Mike asks, the recommendation to install solar on a new roof is based on the fact that otherwise my return on investment will be lower, correct? Or are there any other reasons? In other words, depending on the actual cost to me, it may still be valuable even if remaining roof lifetime is less than 20 years. It is possible. So again, the uninstallation and reinstallation cost can be up to, or maybe even slightly more than $10,000. Additionally, so that's the reason that that's going to be so much cost is partially because it is required by Oregon code and law that electricians perform the uninstallation and reinstallation because it's an electrical system. Electricians have expensive labor. Additionally, they're in high demand and there is a shortage of electricians. So you may find that your solar contractor is happy to send a team out when you need that uninstallation, reinstallation. You may find that there is a delay of several months between when you need the uninstallation, reinstallation, and when you can get on somebody's construction calendar. So there's that additional factor. That's mostly since the pandemic. There's just been all sorts of wonky things with permitting delays and supply chain delays and labor shortages. And so that has exacerbated that a little bit. It doesn't mean that you can't find somebody. However, note that some solar contractors only work on installations, and when it comes to maintenance and other services like that, they only work on installations that they installed. That's not true of all installers necessarily, but just note that that can also be a factor there in terms of when you are able to find somebody. However, that's even with the excess cost, it may be that your system is still a net positive over the lifetime of the system. We've got a question. Do you expect net metering to be phased out in the near future? This is a great question. It's also a really hard question to answer. Net metering the policy has changed in California, and that's been in the headlines. California is ahead of pretty much every other state in terms of the amount of solar installed on their grid. And there are just technical reasons why net metering is a policy. It's a great policy, exists in many states. But it's a policy when the grid, that makes sense when the grid has lower saturation levels of solar. As soon as you get a lot of solar installed in the grid, net metering becomes a little bit less financially feasible on a societal scale. And so that's why that policy changed in California, is just because solar has been so successful in California. I don't expect net metering to really be phased out in the near future in Oregon. The utility companies certainly would like to get rid of it. And there have been, legal motions for years, for over a decade, that the utility companies have put in at the regulatory department of the Public Utility Commission to try to nip away at it. It is an active, policy question. However, I think that there's much higher priorities for the utility companies in the near future. I can't really estimate, but note that even in California, I believe that existing net metering systems are grandfathered in. And so they won't experience the changes to net metering that are going to come with the new program, I believe. I need to research that and double check on that for you, but I believe that that's the case. And it may be the case that that would be how it would happen in Oregon or not. I can't really say. Todd asks, and it looks like this is our last question, unless anybody else throws another one on. During an outage, will the solar continue to charge the battery? Yeah, so that's one of the great things about solar plus storage is that if you were to just install a battery, 10 kilowatt hours of capacity is going to last you a lot less, and it's going to take you much further, less. It's going to take you not as far, as if you had solar panels to recharge that system. And so when you install solar plus storage, it really extends the useful life of the battery during the use case of an outage. And that's why it's such a great combination. Thank you guys so much. I appreciate it. I always enjoy this. I enjoy answering questions. Again, there's going to be a link. I'm going to send that out in the email. And feel free to email, get in touch, zach.s@solaroregon.org. The link is in the chat here, and I'll send that out in the email as well. Hope you guys have a great week, and good luck on your solar journey.